In our last two videos, we talked about multiplying a polynomial by a monomial, and then how to simplify expressions using that same concept. And now we're going to talk about how to solve equations involving that same concept of multiplying a polynomial by a monomial. So let's just take a look at the steps, and you can always pause this and write these down if I'm going too fast. The first one is to open any parentheses with the distributive property. Okay, we've done plenty of that in the last two videos. The next step is to combine like terms. We've done that. The third step is to move variable terms to one side by adding or subtracting. That's a concept that we've used quite a bit in the past when solving equations. And then the fourth step is to solve this like a two-step equation. Okay, so let's just take a look at our first example. Our first example is 3 times y minus 2 plus 2y is equal to 4y plus 14. Well, we do have some parentheses that need to be opened, so let's take a look at that. We need to multiply what's inside, the difference inside this parenthesis, the difference between y and 2. We need to multiply both of those by 3. So let's take a look at what that looks like. We're going to end up with 3 times y is 3y, 3 times negative 2 is negative 6, and then we're just going to bring down the rest of the equation that we haven't used. You can see here that I've color-coded the like terms. That just helps me as I work my way through this. The next thing we're going to do is combine like terms. I see on this side of the equation I have a positive 3y here and a positive 2y here. I can combine those for a sum of 5y. Now I have 5y minus 6 is equal to 4y plus 14. So let's go ahead and get the variable terms on the same side. I like to keep my variable terms positive, so I'm going to subtract this 4y from both sides. When I do that, it's going to cancel out on this side. Over here, I have 5y minus 4y, which is just simply y. So we have y minus 6 is equal to 14. Well, as you can see, it resulted in a one-step equation, not a two-step equation. So let's go ahead and isolate y. They're subtracting 6, so to isolate y, we need to add 6 to both sides. When we do this, negative 6 plus 6 is 0, and y plus 0 is just y. And 14 plus 6 is 20, so we have y is equal to 20. All right, take another look at another example. On this one, its only difference is that we have parentheses on both sides that need to be opened up. So let's take a look at it, what we're going to need to do. Again, I've done some color coding of like terms. So on this side, we need to multiply the sum of 4x and 2. We need to multiply those both by 2. When I do, and on the other side, we need to multiply the sum x plus 3 by 4. When I do that, I'm going to end up with 2 times 4x is 8x, and then 2 times a positive 2 is plus 4. And then I'm going to bring down my subtract 8. On the other side, 4 times x is 4x, and 4 times a positive 3 is positive 12. On the left-hand side of the equation, I can combine the terms 4 and negative 8. When I combine those two terms, I get a negative 4. So I'm left with 8x minus 4 is equal to 4x plus 12. Now let's move the variable terms all to one side. I have a positive 8x and a positive 4x. Let's subtract the 4x from both sides. It'll cancel out here. Over here, 8x minus 4x is 4x. So we have 4x minus 4 is equal to 12. Now we've got a two-step equation. If you remember, on a two-step equation, we're going to undo the subtraction before we undo the multiplication. So to undo minus 4, we're going to add 4 to both sides. This will result in 4x is equal to 16. Now to isolate x, since they're multiplying by 4, we need to do divide by 4. When we do, the 4's will cancel out here, and we're going to wind up with x is equal to 4. As always, I hope this sheds a little light on this topic. Remember, you can always reach out to us if you have any questions, and I hope you have a good one.